Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to be working on the electron configuration of silicon atom. The first thing you have to do anytime you're given an electron configuration question is for you to determine the number of electrons in silicon. Now, since silicon atom is an atom and it's not an ion, meaning it's not a cation or an anion, meaning it doesn't have like Si plus or Si minus, it's just Si, meaning it's just an atom, right? You have to know that the number of electrons and the number of protons in an atom is the exact same number. And the way you determine the number of protons or the number of electrons in silicon atom is to just look at the atomic number in your periodic table. So the atomic number of silicon is 14 and the number of protons for silicon is 14. So for atoms, remember that the number of protons and the number of electrons is the same. So we have our number of electrons for silicon to also be 14. Now, the next thing you have to do is that you're going to fill up each one of this electron in the energy orbital diagram here, and you're going to fill up from the lowest energy orbital, from the lowest energy orbital, which is 1s, to the point where all 14 electrons have been filled up or used up. So we're going to start with 1s, the lowest one. So we have 1, 2. And by the way, you're going to put 2 electrons in each orbital until you use up all of the electrons. So you have 2 electrons added, and then you have 3, 4. So you've got 10 electrons left. And then you have 5, 6, 7. Now, one thing you need to know before I fill up is anytime you're given an orbital diagram, always fill up each orbital if you have more than one orbital. So for the p orbital, there are three mini orbitals. You've got the first one, the second one, and the third one. So before you can fill up all three of them, you have to fill up each one of them first, because since electrons are negatively charged, putting 2 electrons in one orbital, putting 2 electrons in this case in one box, is not a good idea, because since they are both negatively charged, you're going to repel each other, causing energy destabilization. So it's best for you to put them in different orbitals, hence here in this case different boxes, before you pair them up. So we filled 7. Now we can pair up. So we have 8, we've got 9, we've got 10. 10 electrons filled up, we have 4 left. And then we can say 11 and then 12 and then 13 and then 14. So in this case, I'm also filling up each box before pairing them. But we've used up all 14 electrons, so we're done. So one thing you have to now remember is for this, we're going to have 1s2, 2 meaning the number of electrons in the 1s orbital, and then you have 2s2, and then you have 2p6, meaning 6 electrons in each one of, meaning 6 electrons in the 3 p orbitals combined, and then you have 3s2, and then you have 3p2. So our answer is going to be, for electron configuration of silicon, 1s2, 2s2, 2p6, 3s2, and then 3p2. And this is our answer to the electron configuration of silicon. So you have to make sure that the order is filled correctly from the lowest energy orbital to the highest. And you also have to count that the number of electrons count and match up to 14. So you have 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 2 is 14. So we can determine and confirm that we solved this correctly, and the electron configuration of silicon is 1s2, 2s2, 2p6, 3s2, and 3p2. If you want to know how I solved the electron configuration of other atoms on my channel, make sure you click on the video on the screen. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.